The title of this session is Energy and Pointing Theory. In this session, we will discuss how the EM wave carries power. We consider a current density J. The power per unit volume imported to J. This means that the power dissipated by J is defined as E dot J. The power loss due to J is E dot J. So let's see how to express E dot J. We write E dot J here, and for J, by using the Maxwell equation, we know that J can be expressed as curl H minus partial D over partial T. And then we expanded this equation, we will have E dot curl H minus E dot partial D over partial T. Okay, to find out the item here, we have used the vector formula. As we know, if you perform divergence E close H, we expand this term, we will have H dot curl E minus E dot curl H. And clearly you can see that this one is the same as this one. So we can replace this term by this equation. So we will have minus divergence E close H plus H dot curl E, and write the following term here, E dot partial D over partial T. Then again, by using the curl E equation, we can replace this one. Then we will have divergence E close H minus H dot partial B over partial T. And the final one is E dot partial D over partial T. Okay? And this is hard for us to understand the physical meaning right now, so we have to perform some arrangement. Before that, we have to define each item here. So first, let's consider this one, E dot partial D over partial T. As we know, the D field can be expressed as epsilon E, like this. And our next step is to put the E field inside here, so we then can have partial over partial T, and the following is epsilon E dot E over 2. Then this means that it will be partial over partial T of half epsilon E square. Do you remember what is this term? Half epsilon times the square of absolute value of E means that This one is the electric energy density. So E dot partial d of partial t is the time rate of electric energy density. Similarly, you can find out that H dot partial b over partial t will be partial half mu the square root of absolute the square of absolute value of H. And again, this one is the magnetic energy density. Okay, since we have find out the meaning of these two items, let's rewrite this equation. Then we will have minus partial u over partial t equals to divergence S plus J dot E. In the above equation, we have some definition where U here means the E dot D plus B dot H over 2. And this is the summation of electric energy density and magnetic energy density, which means that U here is the total EM field energy density. Okay, and as here, by compare this equation and this equation, you will know that the S here is defined as E cos H, and we call it Poynting vector. The physical meaning of this Poynting vector will be explained later. And to understand this physical meaning, we have to use the integral form. So for this equation, let us perform the Wallen integral. So to perform the Wallen integral, you will have minus partial over partial t. Inside the integral is the u dv. Okay, and for the right hand side, we also perform the Wallen integral. And first one, we perform the Wallen integral of divergence S. But according to the divergence theory, this will be equal to the total outward flux of S field across the surface S, which encloses the Wallen. And for the second term, it will be the Wallen integral of J dot E. Okay. And now let's see. So as I have mentioned, U here is the total EM energy density. So the Wallen integral of the total EM energy density will give you the total EM energy. So this Wallen integral is the total EM energy density. If you perform the partial over partial t, this will give you the EM power, and minus here will refer to the total lost EM power. Okay, so on the left hand side here, this means the total lost EM power. And what is the corresponding right hand side? For this term, inside the integral j dot e means the power dissipated due to j. So the power density dissipated due to j. So the volume integral of this term means the total power lost due to j. Okay, so let's see. Here is the total power lost, and here is the power lost inside U because J. Then what is this term? What is this term? This term will correspond to total power outflow. This means that the total power lost in this volume has two reasons. One is the power dissipated by J caused by yourself, and the other is the power leaked out from this volume. Okay? So this surface integral will give you the total power leaking out. As a result, this S vector is defined as the outflow power density. So this is so-called Poynting theory and give us the Poynting vector. S is the E close H, which means the power outflow, the total E close H is the outflow power density. By performing the outflows of the S vector, you will obtain the total outflow power.